All right, so how do we graph a parabola, or a quadratic, I guess? What do we start with? What formula? So opposite of b over 2a, which is going to find us the what? The axis of symmetry, which is what variable? The x. So we're going to find the x. And so the opposite of b here would be what? The opposite of b. And then what's a? So then it ends up being negative 4 over 2, which reduces to what? Good. So then immediately, which I saw nobody do, immediately draw your axis of symmetry. Okay, so that's step 1. What's step 2? Plug that number into what? The equation. So in both of the x's, so negative 2 squared plus 4 times negative 2 minus 4. What's negative 2 squared? 4. What's 4 times negative 2? Negative 8 minus 4. So what's 4 minus 8? Negative 4 minus 4? Negative 8. All right, so negative 8. So then that means my vertex is what? Negative 2, negative 8. Your vertex is not negative 8. The vertex is the whole coordinate. So now I plot that, which is at negative 2, negative 8. And then the last step is to do what? Plug in 0 for x. So 0 squared plus 4 times 0 minus 4, which means my y-intercept is what? Negative 4. All right, so negative 4. And then what do I do last? I have to mirror it. Where does it mirror? Over which way? Am I mirroring this one or this one? The y-intercept? How come I mirror the y-intercept and not the other one? Well, if I mirrored the other one, that would still make a U shape. But it'd be going down. How do I know this one should be going up? Because A is positive. And the other reason I mirror the y-intercept is because where should the axis of symmetry be? In the middle. And if you mirror the vertex instead of the y-axis or the y-intercept, your axis of symmetry would not be in the middle. So that's why I say do that right away. Put the axis of symmetry right away because it's a good way to check yourself. You also can check yourself because if you do it wrong, then you're going to be opening the wrong way. Okay, so always be able to check yourself that way. But for the most part, people caught their mistakes and did a great job with that. So good work. All right, so there's 3 steps. So again, you can, in life, when you graph a quadratic, you can do it this way, or you can do it by finding the table on your calculator and doing it that way. Either one is fine, but for this quiz and this test, you will have to be able to show me that you can do it this way. Okay, so you'll have to be able to calculate it using these 3 steps. I find that the more you do it this way, you'll probably tend to end up doing it this way instead of finding the table and plotting the points, just because once you're practiced at this, it goes really quickly, and it ends up being a little bit less work. Okay? So I don't care which way you do it, but you have to know how to do it like this for this test. Okay, so the last thing we're going to talk about this, I guess, quarter 3, is how we transform quadratic functions. So I want you to sit and think back to when we did linear functions, and we said a linear function is written in the form y equals mx plus b, where the b is the y-intercept and the m is the slope. So do you remember how we said if you change the y-intercept, your line basically moves up or down? And then if you change the slope, your line either gets steeper or less steep, like kind of flatter, right? Remember how we talked about that? So so the slope man will tell you as it moves towards horizontal, it's getting closer to 0. As it moves towards vertical, it's getting bigger. So the line gets steeper or shallower, I guess. So those are transformations of linear functions. Today we're going to talk about 2 transformations of quadratic functions. And again, to transform just means what? What does it mean to transform something? To change it, to switch it. So if you when you see a dramatic transformation on like a makeover show, right? Somebody went from they get their hair done and they get their makeup done, or like TLC What Not to Wear is a dramatic transformation because they start looking like a slobby mess and then by the end they look like a runway model, right? So, okay, take me down that path. Okay, what happened there? Oh, yeah, perfect. It's in the name, right? So a transformer goes from being like a bumblebee is like a yellow car, and then all of a sudden bumblebee transforms into some big robot, right? All right. Okay, so transform means to change. So when we're talking about transforming a quadratic function, we're talking about changing it from the parent function. So remember, the parent function is y equals x squared, because that's our basic quadratic function. And that one starts where? At 0. It starts right at the origin. Okay? Now, before we do this, before we talk about these transformations, what we're going to talk about is we're going to talk about two things that are going to change. We're going to talk about the quadratic getting wider, so a parabola going from here to like out here. We're going to talk about it getting narrower, which would look like that. So we're either going to talk about getting wider or narrower, or we're going to talk about if it moves up or down. All right, so those are the two transformations that we're going to talk about here. So getting wider or narrower and moving up or down. If it gets wider, that means it goes further out than the parent function. If it's getting narrower, that means it would be further in than the parent function. And then if it moves up or down would just be if it's above the x-axis or below the x-axis. Okay. So how can we identify that? So take a look at these three different quadratic functions. The red one is our parent function. What's happening to the green one? Is it wider or narrower? It's wider. It's further out than the red one. What about the blue one? It's narrower and it's upside down. Okay, so first things first, let's take a look at the equation of the green one. What's different about the equation of the green one than the equation of the red one? It has a coefficient, and that coefficient is a fraction, which means is it bigger or smaller than this one? Smaller, because what's the original coefficient? If there isn't one here, what is it? 1. And is 1/2 bigger or smaller? Smaller. So as a, remember a is the number in front of the x squared, as a gets smaller, what happens to the graph? It gets wider. All right? So that's kind of like the opposite of what you might think. But as a gets smaller, the graph gets wider. As a gets larger, like down here in the blue, 3 is bigger than 1, what happens to the graph? It gets narrower. All right, it gets narrower. And then how come this one's upside down? It's negative. So when a is negative, that means it flips and it's upside down. Yeah?
So like, what if it gets like too big and it just goes like
doesn't fit on the graph?
Does it go like that, or does it just go straight line?
Too big or too narrow?
Too narrow.
So if it gets too narrow, does it ever smash together? No, then it would no longer be a quadratic. Then it would be a linear function like y equals x or something. Okay, or sorry, no, it would be like x equals 0. Yes, it goes narrower, 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 and then as soon as it gets to the point where it would be like on top of each other, a straight line, then it would have to be x equals 0. So then it would no longer be a quadratic. So it is impossible for a quadratic to get so narrow that it disappears. All right, so again, as a gets bigger, the graph gets narrower, which is the opposite of what you would expect. As a gets smaller, the graph gets wider. Okay, so if I give you these functions, all right, if I give you these three functions, and remember, I can cross out all of these and just change them to what letter? Y. So this is just function notation to indicate that these are three different functions, but all of those things just mean y equals. All right? If I want to figure out if it's narrower or wider, I only look at the coefficient a. So I only look at a. What is a in this case? A equals 1. What about in the second one? 1/3. And then in this last one? A equals 5. Okay, I want to put them in order from narrowest to widest. So what would be the narrowest one? Remember, it's kind of flipped from what you would expect. So the narrowest one here is F, G, or H? Esmeralda? H. It's H because as A gets bigger, what happens to the graph? It gets narrower. So the narrowest one is h of x because that has the largest A value. The widest one then would be which one? So g of x, because as A gets smaller, the graph actually gets wider. All right, and then what would be the one in the middle? F of x. That's just how you say function notation. It's like the function for every value of x if x is this thing. So we say f of x because that stands for the whole line. If I said f of 3, then that would be where is it at when x is equal to 3. But if I say f of x, that means for every number that x could be, what's the function look like? All right, so the middle is f of x. So again, it kind of goes a little bit backwards for what you would think. The narrowest graph is actually the largest A value. All right, so when you're looking for width or narrowness, you just look at the A value. Does anybody have a guess on how you can tell if it's going to move up or down? Not open up or down, but if the actual vertex moves up or down? Esmeralda, what do you think? Not necessarily if it's positive or negative. That would be if it opens up or down, and that's perfect. So if it's negative, that means it opens down, right? If it's positive, that means it opens up. But what about if it's like, here's our original, what if it moved to start down here? Does anyone have a guess on how you would move it up or down? The y-intercept, exactly. Which, let's take a look back at the very beginning. What was our y-intercept of this graph? -4. Does anyone see where that might come from in the equation? Yeah, does anyone see where that might come from? Letter C in the equation is your y-intercept. Because if you plug in 0 for these first ones, what's always going to happen? It just goes away. So most of you started figuring that out and didn't even do the plug-in work because you just said, well, that's 0, that's 0. So this ends up being your y-intercept. So you don't even need to plug in 0 necessarily because you know that your y-intercept is just going to be whatever the C value is. So for instance, in this graph right here, what's the C value in the parent graph? If there isn't one, what do you assume it is? 0. So the C equals 0. What's the C value in this graph? -4. And what's the C value here? +3. So the red one is right in the middle because it starts at 0. The green one, because C is equal to -4, moves down where? To -4. And then the blue one, because it's +3, moves which way? Up 3. Okay, so the y-intercept, that C, tells you if it's going to move up or down. So remember, again, think back to when we did this with linear functions. Your answers on a test or quiz for questions like this, I'm going to say, how does this compare to x squared? And you would say, for this one, it's the same width because A is still equal to 1, but you would say it moves down 4. So your answer would be same width, moves down 4. Here it would be same width, but moves up 3. Okay, so those are the two things you're going to have to say. Is it narrower or wider? And then does it move up or down? Okay, so go back, Brendan.
So is it narrower or wider?
Right now, these are the same width because they all have the same A value. But if this were 1/2, then you would say it's wider. It's wider and moves down 4. And the whole point of this is that you don't have to spend the time to actually graph it because you can just look at the A value and the C value and tell before you even graph it. Because otherwise, a question like this where I said, order these from narrowest to widest, would take you a long time because you'd have to table all 4 of them, put them all in order, or sorry, 3 of them, and that would take you a long time. But if you remember, for narrower or wider, what letter are you looking at, A or C? We're looking at A. What's the A for this one? -2. What's the A for this one? And what's the A for this one? 4. So remember, the narrower it is, that means the number is getting bigger. So what's my narrowest graph here? So that would be h of x. And then what would come next? No, f of x, because we ignore the negative. The negative just tells you what? That it flips downward. Okay, and then the last one, what would be your widest? G of x. Okay, so rather than having to graph all three of those and taking forever to do that, and I'm not saying you guys take forever, I'm just saying in general that would take a long time. Rather than having to do that, you just look at your A's. Okay. All right. Brendan.
So if there was a case where it was a negative 2 and a positive 2,
They're the same. Those would be the same width. But one would be opening up and one would be opening down.
it doesn't matter like which one you put in first.
No. I won't do that though, because I'm not going to do that. But yes, it would not matter which order you put them in. Okay, so what about this one? Which one is the narrowest here? Oh wait, I'm going to do it right now.
You did. They're the same.
These have the same width. All right, these are the same width because they both are 2. The only difference is that which way does f of x open? Up, and then g of x opens down. Good. Okay. All right. Neither of them have a y-intercept, which means where do they both start? At 0, at the origin. These would both start at the origin. Good. Okay. All right, so then for this one, how would this graph be different than the parent graph y equals x squared? So again, you have to answer 2 questions. Is it narrower or wider? And then does it move up or down? So in this case, is this narrower or wider than x squared? What's the a value of x squared?
1.
What's the a value here? 1/3. So when it gets smaller, the graph is actually getting wider. So this is wider. And then what's the y-intercept of x squared? 0. What's the y-intercept here? 2. So does it move up or down? How many? 2 up. Moves up 2. Okay, and then as a bonus point, does this open up or down? Opens down, so it faces downward. If you put it on there, sure.
It's easy.
All right, so it opens down. Okay, so on your practice, for the first section, you're ordering them from narrowest to widest. Don't write the whole function, just write the letters. Okay, so f of x, g of x, f of x, g of x, and I think there's some h of x's. And then for the next one, you're telling me you're comparing this graph to the graph of f of x. But again, don't graph them. Tell me if it's narrower, wider, and then if it moves up or down. Okay? So you're going to do all 8. Go.